Okay guys, welcome back to part 3. Yeah, I'm using the other monitor as a kind of a mirror right here because I want to make sure that the diagrams I'm showing you for our talk about hurricanes here on our April 6th still continuation of severe weather, but are where you can read them and they aren't in reverse. So we're talking about hurricanes right now. Okay. You guys are familiar with our mid-latitude cyclones, which we have spent a lot of time talking about. Well, they occur in the mid-latitudes, but once you go down to the tropics, you're going to have tropical cyclones that form. All right, they're going to be secondary level cyclones, just like the mid-latitude cyclones were. Most of them are going to have, again, about a week to 2 weeks of lifespan, and there are hundreds that are formed every year down in the tropics. But every now and then you will get a just regular old tropical cyclone that becomes extremely severe. I'm going to move down to a map here, and will turn into what is actually a hurricane. For a tropical cyclone, which is just regular old storm, for it to be declared a hurricane it has to have sustained winds of at least 75 miles per hour. Now, the winds can get up to 200 miles per hour in stronger storms, but it's got to be a minimum of 75 miles per hour to be deemed a hurricane. All right. Now, here's a map showing you where hurricanes tend to form. Now, in order for, the ingredients a hurricane needs is number one, it's got to have warm water. In fact, I'll go ahead and show you guys this right up here. All right. Ocean water anywhere within the upper 70s to 80 degrees is needed, so you have enough heat to get lots of evaporation going, because we know that warm air is going to cause, can hold more moisture and has a faster evaporation rate. And that's what's going to get it rising up. Now, you've also got to have a low pressure system. That's why you got to start out with, already a tropical cyclone in its version. All right. So you got warm water, and then you've got humid air that's rising up. One thing you cannot have is wind shear. So the element that is so important for supercell tornadoes will kill a potential hurricane. So you got to have pre-existing winds that are all blowing in the same direction at the same speed, because wind shear will tear a hurricane apart. So no wind shear, all right? And then you've got to have, of course, very humid air, which you're only going to find the super humid air is going to be over oceans. As that starts to condense, that's going to give you the latent heat of condensation. There's your energy source for the hurricane. So the original energy source is always going to be the water. Okay, the warm water is the key to hurricanes. Once you run out of warm water, it's going to fall apart. Now, something you also have to have is the Coriolis. These are very large. These are, again, they're regular secondary level cyclones, like the mid-latitude cyclones, and you do have to have the Coriolis effect to get it kick-started, okay? But to sustain it, you have to have the warm water. This is why they will die out once they reach land, all right? But let's look at where the tropical cyclones form. Now, so of course we're talking about the tropics here. And one thing you guys may remember, now we know in the mid-latitudes, all right, winds, the upper air westerlies, the geostrophic winds are blowing from the west toward the east. And that's why for most everybody up here in the mid-latitudes, including everybody in the United States, while our storms move from the west to the east. It's why we look to Arkansas before it hits us. But if you'll recall, the geostrophic winds within the tropics, okay, from about 15 degrees or so north and south, those guys move to the east, all right? So our tropical cyclones are going to move from a east to west pattern. And where the hurricanes then form are generally, again, they're very early, just tropical storms tend to form on the western part of oceans, okay? But then they move to the west, I'm sorry, they form on the eastern parts of the oceans and move to the west, all right? And this way. And so this is showing you where most of them form. So they're forming over the oceans. They're forming in the tropics. They're not going to form up here in the more northerly reaches or way down here in the far southerly reaches of the oceans because the water is not going to be warm enough there. It's going to only be warm enough in the tropics. All right. So you notice we don't have any forming right on the equator because even though we got lots of warm water right on the equator, if you can recall what we do not have at the equator, and that is going to be the Coriolis force. So they don't form right on the equator because they do need the Coriolis to help basically kickstart them, okay? Going on. But everywhere else, they're within the tropics, we see them forming. The only place we don't hardly ever see them forming, which you would think right off the bat, is right down here off the coast of South America. But what keeps this region, even in the tropical region, from forming the different hurricanes is that there tends to be a lot of wind shear here on a regular basis. And so it's very, very rare for one to form here because of the wind shear as it goes on. All right. You may already know this, but if you ever hear the word typhoon is just a hurricane. Okay, sometimes these are just called cyclones as well. Some places just call them generically cyclones. They're all hurricanes. They're all interchangeable. Usually out here in the Pacific Ocean, all right, in this area right over here, this is where you hear the name typhoon. So usually you'll talk about a typhoon that hits the Philippines or Japan or something like this. But it's exact same storm, just a different name, all right, that goes on. So, all right, so these are the things that you know. Now, one thing hurricanes, the way they are organized, they looked very different from the mid-latitude cyclones that we talk about. I mean, it's still a cyclone. It's a low-pressure center that forms, but these are extremely organized storms. So this is, again, the reason that you can't have the wind shear, all right, that is in it. So I'm going to show you several diagrams of what they look like. Your typical cyclone or hurricane is going to be anywhere from 100 to 400 miles across. So these are very, very large storms. That's why they are actually affected and influenced by the Coriolis effect because they are so large, all right, just like a mid-latitude cyclone. But one thing that is unique about the hurricanes is it's actually a spiral, all right? Now, what you're used to seeing, hang on, let me find a pic here of an actual hurricane. When you see in pictures, let me swing over here, all right? It looks like this. Just, one big, giant poof of cloud, all right? Cloud as far as you can see. But in reality, you have got a spiral. Let me back away so you guys, I'm going to have to stand up for this one. All right. It is a spiral of thunderstorms. All right. I mean, it's literally going in a big spiral like this. And so you have multiple bands here and with lulls in between. All right. If you've ever watched footage when people, are on the coast and a hurricane is coming through, that'll be super windy, super rainy spells, and then there'll be a little bit of a lull. I mean, it's still rainy, and it's still a little windy, but not as much, but then you'll get another surge that comes through, and then it breaks off. That's because it's these different spiral bands that are going on here. Let me show you another picture diagram where you can see the different, not very well, there you go, the different bands of the clouds. So multiple bands of clouds. And yes, they're at the center. Here's a shot of a radar version of it with the red being the heavy rain. All right. And of course, they're also very famous because they have that eye. You can see it in this picture right here. All right, that is the very center of the low pressure. And usually the bigger the storm, the more intense the storm, the lower the pressure it is at the center. All right, so extremely low pressure. Yes, at the eye of the storm, it is clear. All right, because right at the very center, there is actually a little bit of subsidence that goes down. And these eyes can be anywhere from about 20 to 40 miles in diameter. Can take anywhere from 20 minutes to an hour for them to pass over an area. All right, and there'll be birds and stuff sometimes that are trapped in that a little clear space that goes on where there's like zero wind whatsoever because it's right at the center. All right, you can see the warm air is actually spiraling up around it. So it's just like a whirlpool that goes down a drain where it's kind of clear in the middle. All right, that's the same thing that's happening up in the air. All right, so that's what it looks like. But again, it's because of the pressure differences with the extreme low at the center and then higher pressures as you go out that, of course, you know, you have a steep pressure gradient, and that's what's going to fuel all these strong, strong, strong winds that can happen. Now, out in the open ocean with one of these hurricanes, granted, you wouldn't want to be on a ship in the middle of one, but other than that, it doesn't really cause any damage. You know, the fish don't care, the whales don't care, they're way down under the water, and, you know, they're out of the winds and things like this. But when it becomes dangerous for creatures and humans is once it hits shore. Because what happens with that is, yes, you get a lot of rain, which we can see, you know we have problems with that. You can get some very high winds, which, yeah, we know you've got damage from high winds. But what most of the damage occurs with a hurricane once it reaches land is actually flooding. It is from something called the storm surge. And this helps explain what the storm surge is. Now, again, out in the open ocean, of course, with low pressure, we know anything that flows, such as air, is drawn up into low pressure. Well, water flows as well. And you end up with this mound of water, just like if you're sucking water up a straw, you know, like if you put a vacuum cleaner into your fish tank, it's going to cause the water to rise up just a little bit. All right, so you see that mound of water right there close. Usually, instead of being, you would think it would be right at the eye, but it's usually a little in front of it. Don't ask me why. Don't worry about that, okay? But again, out in the open ocean, this is no big whoop. It's no big deal. But once you come onto shore, when the water becomes much more shallow, you know, we get out of the, mile deep or 2 mile deep ocean water, and that's what really causes this mound of water to surge up. All right, this is called a storm surge. Let me show you another picture here. And again, it is this flooding that causes the most damage on land. Now, one nice thing about hurricanes, as far as when they're heading toward the coast areas and stuff like this, is we generally have plenty of warning. People have time to prepare for these. It's not like a tornado that, boom, just happens out of nowhere. Here, you often have several days in advance to go, we're in the path of a hurricane. So you can take measures. You can basically bring things that are going to be flying around, bring them inside, your lawn chairs, your cars, or whatever. You can board up your windows. You can batten down the hatches. You can do all kinds of things to actually prepare for a lot of that wind, all right? But what you can't prepare for is the flooding. This is showing an example. Of course, the stronger the storm, they come in categories, of course. The stronger the winds, the stronger the category, all right? But also the stronger the winds, the stronger the storm, the more the storm surge. So this is showing you like where the blue line would have been where the normal high tide is. And then it comes in and it ends up flooding these areas. Now, just flood in and of itself is bad. You know, you can cause damage. But keep in mind, we've got a lot of wind blowing. And wind blowing over water makes waves. And so these storm surge, yes, you've got water coming in and flooding, and some of it can move quite fast, but you've also got huge waves in this, which act like battering rams, wrapping up against the foundations of buildings and trees, and literally will knock them down and wash them away. All right, so I'm going to show you another pic with the storm surge. All right, this isn't here another way of showing you. Here's your normal high tide, and then again is the different categories up to a 20 foot higher than normal that goes on. And again, keep in mind, these guys have got 100-mile-an-hour winds backing the waves. So imagine being hit in the face with a bucket of water constantly coming against that. So let me show you some damage. All right, so here's an area. Get rid of that. There you go. There you go. Okay, there on the left is the area beforehand. This is down, this is Orange Beach, Alabama. Okay, and there it is after. You notice there are much fewer houses, especially look at the one back here in the back. This looks like I don't know if that was a convention center or a restaurant or church, who knows what that is right there, some big red building, but it's completely gone over here, as totally washed off. It's these storm surges that will carry ships that were in a harbor up to a mile inland and dump them. Okay. And again, totally wipe houses completely off. It's the map. Way back in 1969, there was Hurricane Camille that hit down on the Gulf Coast, off the coast of Biloxi. And there was a group of people who decided to have a party. They were in an apartment building that was located, would have been right here. Okay, the same type of deal. It was, you had the frontage road that runs down the coast of Biloxi. Wasn't right on the coast at all. It was a little further back. Okay, and they were like, "Woo, we'll be safe." And they had a party, invited a bunch of people over. Well, they never found anything again because it looked just like this once the hurricane was over with. All right, this is a hurricane that literally split an island in two. There's some barrier islands right off the coast known as, now it's East Ship Island and West Ship Island. It used to be one ship island, and the hurricane literally washed out the center of that island as well. All right, so this flooding, because of the storm surge, that is what causes the most damage from hurricanes and things like this. And that's one thing, again, most folks don't think about, okay, or don't realize, especially if you don't live down there. All right, but now people talk about how